Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of the chapter sets in mathematics. We understood already one example where A union B, A intersection B and A and B were involved. Basically two sets were involved. Alright. Now what if you have three sets? We have already understood the formula. Okay, now let us understand the Venn diagram if three sets are involved. So I have not named any set here, so let me name it. This is A and let me name it as B and C, and this rectangle that you see is universal. So what is A? A is this circle and B is this circle and C is this circle. Well, okay, so now I have named the regions 1, 2, 3, 4, 5, 6, 7 and 8. Let us understand what do they represent. Okay, so once you understand what they represent, suppose this question is asked only A. So where do you go? Only A. Only A is this region. So if you have that number, okay, fine, that's the answer, that's it. So answering the questions based on these three sets is very easy if you go for the Venn diagram. Alright, so that's what I suggest. Now, what is the first region represent? The first region represents the intersection of all the three. So this is the region, smallest region in this is the intersection of A, B and then C. Do you see that? So this is the common point where all the three sets meet. Well, so that is the intersection of all the three. Now, what about the second region? This region. Only this region, that is A intersection B. See, this is A intersection B. From that you have to subtract C. Okay, so that is A intersection B except C. C is not there. So A intersection B intersection C dash. Okay, so that means common region of A and B. Okay, but it is not common to C. It is not common to C. Now third and fourth are similar to second, so that is understood. So that is B intersection C except A and A intersection C except B. Well, now what about the fifth region? The fifth, okay, before fifth we have 1 plus 2. Okay, so what is 1 plus 2? See this region. 1 plus 2 is yes. So you have A and you have B. So that is A intersection B. Well, so that is A intersection B. And what is 1 plus 3? See, 1 plus 3 is B intersection C. 1 plus 4, this region is A intersection C. Well, okay. Now, what about fifth? Fifth is only this region. Okay. So that is only A, of course. So this is only A, and how do you write only A? See, only A you can write A intersection B union C whole dash. B union C is not there. Okay, that means B is not there, C is not there. How do you read this? It is the set in which you have A and not B and not C. A but not B but not C. Okay, so it is only A, exclusively A. Alright, so then 6 is only B. Okay, so from B subtract A and whatever you get remain from that again subtract C. So basically what are you doing? From B you are subtracting A and C. Okay, so from B you are subtracting A and C. If you do that, you get only B. And similarly you have only C. You can use this formula. It is C but not B but not A. Not A and not B and C. Okay, so this is not A, B and not C. So everywhere you have and. Well, next the last one, eighth. Now what about this eighth region? Say if A union B union C is equal to universal, then eighth region will not have anything. But eighth region will have something if you have the elements which don't belong to A, B, C. So this is none of A, B, C. None of A, B, C. It is not A and not B and not C. There are some elements in the universal which are not in the union of all the three. So there are some elements in the region, in the universal set, which are not found inside these. So those will be none of A, B, C. Okay, so that is about this Venn diagram and the regions they represent. Now let us solve a question regarding this. We are beginning the concept of binary operations. Let us understand in the very outset what is a binary operation. A binary operation star, that's the notation, on a non-empty set A is a function star from A cross A, Cartesian product, alright, to A. So all the elements must be taken from the set A, alright. So how does an element in A cross A looks like? Ordered pair. So you are applying the function star to the ordered pair A comma B, and what is the output that you are getting? A star B, and that is a single element, a single answer, and that output must belong to A. Then we say star is a binary operation. So if the output does not belong, then that is not a function, because there are some element which are not related to any elements of A, right? So then it does not become a function, hence it will not be a binary operation. So basically binary operation is a function. And what kind of a function? It is a function from the cross product of A to the set A. Well, now you have some properties, laws, which satisfied by the binary operation star. And if you are taking the set A and the binary operation star, then what is a commutative law? A star B must be equal to B star A. Alright, so for example, A plus B is equal to B plus A, whereas if you write A minus B, that is not equal to B minus A, right? So then it won't be commutative. A into B is equal to B into A. A divided by B is not equal to B divided by A, correct? Okay, so that is the basic thing here. Next, associative law, A star B star C is equal to A star B and then star C. So both must be equal, then it is called associative property, associative law. And all these ABCs are selected from the non-empty set A. Next, what is an identity element? See, identity element is E if it satisfies this rule. What is the rule? E star A must be equal to A star E. So first of all, it must be commutative, and then that must be equal to A. So for example, 5 plus 0 is equal to 0 plus 5 is equal to 5. So 0 is the identity element for addition in integers, you can say in integers, right? So next, what is the inverse law? Inverse law. Understand, you must have an identity for the particular binary operation. If you don't have the identity element, you cannot define inverse. Okay, so let us take an identity element E from the set A for the particular binary operation star, and if A star B is equal to B star A and that is equal to the identity element, then B, which also belongs to the same set, is the inverse of A in star and defined on the set A. Okay, so inverse element of A for star on A, for the binary operation star on A. Well, to give an example, see if you have element 5 and you are talking about the addition, and that must be equal to the identity. What is the identity for addition? 0. Then what is the inverse of a? Inverse of 5. So that will be minus 5. So minus 5 is inverse of 5. So for every a you get a different inverse. So every element has a unique inverse, but the identity element is same for that particular binary operation, whereas inverse changes, because if you take 6 here, then inverse is not minus 5, it will be minus 6, right? Identity element is same, 0 for addition. So every element has a unique one and only one inverse. Well, so that is about the introduction of binary operations, and that's all you have here. Now let us move to the examples.
Don't forget to like our video and subscribe our YouTube channel for all the updates.